Okay, now we're going to be focusing on the coefficients of the equations. Okay, so the coefficients of x squared or x. Okay, because remember previously we only talked about those graphs or equations with the coefficient of x is just +1 or -1, right? So in this case we're going to talk about how the coefficients, when they change, make a difference to the graphs. Okay, so starting over here, I just have our usual y equals to x squared graph, which is just our basic parabola, okay, at the vertex of 0, 0. Now, I'm going to show you when we have y equals to 2x squared. So I'm multiplying 2 to x squared. Okay, so see how the coefficient is now 2 instead of 1? So if it's 2, you can realize that the graph is actually skinnier, okay, so thinner. So you can just like push it a little bit and make it a bit more skinnier. That's basically it. So as the coefficient of x squared becomes greater, the more skinnier it is. So if you see a graph that says y equals to, say, 3x squared, you know that that's going to be a little bit more thinner than this one. So it might look like this. That's the y equals to 3x squared graph. Okay, so if it says y equals to 10x squared, you know it's going to be very, very thin. Okay, does that make sense? That's what it is when the coefficient of x squared increases, but when it decreases, say it's going to be half x squared, it's actually going to get more fatter, more wider. Okay, now make sure though the coefficient of this is between, say I'll just call the coefficient b some number a, it must be between 1 and 0 for this to happen. So if it's like a negative number, we'll consider it differently. But if the coefficient of x squared is in between 0 and 1, so if it's like a fraction or a decimal, okay, then it goes wider, okay, or fatter if you like to call it. That's pretty much what it is. So if it's like a quarter x squared, you know it's going to be more fatter, more wider, okay, like a big bowl. Okay, so that's what you can consider it as. So just remember those two key concepts. If the coefficients increase or if it decreases. Increasing means it's go thinner, decreasing means it's go fatter. Okay, so let's try some questions, starting with question 17. Okay, we're going to sketch both graphs on the same axes. We have first of all y equals to x squared minus 4. Now guys, I'm not going to go through those critical steps again in one by one this time, okay, because I think you guys are more used to doing it now, so it shouldn't be, I don't have to go through it so step by step. So I'll show you how to do those just really quickly. Starting with this one, x squared minus 4. If we're subtracting 4 to the whole graph, we shift to the, push it down, okay? Push it down and it's going to go like that. And if you like, it's a good idea to label these intercepts, but you guys can find that. I won't go through that much detail in the intercepts for now for this section. So when you do have this in your exam though, make sure you label all those critical points, those intercepts, okay? So just by subbing in x equals to 0 and y equals to 0, all that step. But I won't go through that for now, because all I want to do is kind of compare these two graphs, because the next graph actually is the same, but the coefficient of x squared is doubled, it's 2. What did I say when the coefficient of x squared increases? It becomes more thinner, more skinnier. So this graph will become like that. Okay, so it's the same graph, except it's just a little bit more skinnier, that's all. Okay, so the yellow graph represents this one here. Simple? Yes, very, very simple. So let's do 18. So again, it's the same kind of thing. We're drawing both graphs on the same axis, starting with this one. Okay guys, all of you guys should be able to tell me x minus 2 the whole thing squared. If we're subtracting 2 to the x inside that square, which way are we shifting? Yes, to the right by 2. Okay, if we're subtracting to the right by 2. So I just shifted the graph to the right. Okay, now this one, to the whole graph I just multiplied by 2. Okay, if you like guys, if you don't really get why I multiplied by 2 to the whole thing rather than just to x, it's because when I expand this, I'll just do a little bit of expansion for you. It's going to be x squared minus 4x plus 4, right? And then if I multiply by 2, it becomes 2x squared minus 8x plus 8. So you should see, I know this is a little bit different, but you should see that the coefficient of x squared is 2. So it's doubled. The coefficient of x squared is doubled. Okay, so make sure with this kind of one, if it's 2 outside the whole thing, that means the coefficient is basically doubled. Okay, so when you see the 2, remember when we increase the coefficient, we just make it a bit more thinner. Okay, make it thinner, and that's what the graph looks like. So the yellow graph represents the second graph. So it's the same graph as the first one, but just a bit more skinnier. Okay, so that's question 18. Question 19, okay, a little bit more complex, but you guys can do it because we've done so much of this previously. Starting with this one. Okay, so plus 2, which means if we're going x plus 2 squared, if we're adding 2 to x, we're moving to the left by 2 units, okay, because adding means we're going to the left, and we're subtracting 1. So I'll just plot these for you just in case you're confused. So if we're adding 2 to x, we shift to the left by 2, so 1, 2. So there. Now if we're subtracting 1, we go push it down by 1, don't we? So you move 1 unit down, okay? So I'll kind of like rub that off. It's going to be 1 unit down. And then what does the negative indicate? Yes, it just means it's going downwards, downward facing parabola. So just like that. Whoops, I kind of like misplaced the vertex, but anyway, that's what it looks like, okay? So it goes to the left and then go down. That's my graph for the first one. Now, have a look at the next one. The only difference is that I multiplied by half to this whole thing. Similar to the previous question, whereas I multiplied by 2, in this case, I'm multiplying by a half, which means the coefficient have actually decreased by a half, right? So it's a little bit smaller. In this case, what can you guys tell me? It's going to be a bit more fatter. Okay, so the graph is the same, but just a little bit more wider. Okay, so in your exam, you should actually tell me the coordinates of the y-intercepts, and you should realize that they actually change. So the y-intercepts do change depending on the width or the skinniness of the graph. Okay, so make sure you find those in your exam, but that's very easy. Just sub in x equals to 0 and solve for y, so I won't go through that one here, but just keep an eye on that. Okay, that was question 19. Okay, so question 20 says sketch both of these two graphs. Now it's a little bit different to the previous questions because in these questions we can't figure out if it's going left, how it transforms. We can't actually figure out if it's going left, right, up or down straight away by looking at the equation. But what did I say when we have this kind of equation? The most important thing is to find your x and y intercepts. Okay, so I'm going to start by finding the x-intercepts for this one. So just sub in y equals to 0 and just solve it. So I'll just do a little bit on the board. So x here is going to be -1, and for this one, 2. So I'm just going to plot in those points. It's going to be -1 and 2. So it's going to pass through those, and it's going to look like that. Okay, and of course you do have to find your y-intercepts, but I won't do that. Just sub in x equals to 0 and you can find that yourself. That's not a big point in this one. And you should also know that it's going to be positive concavity because it's positive. All the x's are positive and there's positive outside. So this one is what the graph looks like for the first graph. Now we're going to consider the second graph. Okay, so the second graph, there's the same graph, but we are multiplying by a half, which means the coefficient is multiplied by a half, which means it's going to be a little bit less by a half. Okay, half is less than 1. So if it's less than 1, the the width, the wideness, is it going to be more wide or more thin? Obviously more wide because the coefficient is less than 1. So we're going to make it a bit more wide, but just remember guys, it's not the same graph, just making it wider. It's not the same as the previous questions. Just keep an eye on this kind of question because it's not just the matter of making it more wider. Okay, because the previous questions was a little bit more straightforward because we can determine how it transforms, and the only difference was that they just changed the coefficient just directly. But in this case, it's a bit different because we're multiplying by a half to the whole thing. Okay, whereas previously we multiplied by a half or by 2 or whatever to just the x squared or x minus something squared or x plus something squared. Whereas this one we're multiplying by a half to the whole thing, which means there's going to be a change in the y-intercept as well as the vertex. Okay, so what I'm going to do is halve the y-intercept of the first graph. Okay, so for this one, actually I'll just find the y-intercept for you, because it's going to be just 0 plus 1 times 0 minus 2. 0 plus 1 is 1, 0 minus 2 is minus 2, 1 times negative 2 is negative 2. That's the y-intercept. Okay, so this one, it's half of that, which means half of negative 2 is negative 1. Okay, so the y-intercept would be changed, so it's going to be wider and it's going to pass through this y-intercept. It's going to be a bit of a difference in y-intercepts. Okay, the previous question also, there was a difference in the y-intercept, but we don't really have to consider it too much because all we needed to do is just make it a little bit more wider or a little bit more thinner. But in this case, you can actually see a direct change, so make sure you find that y-intercept more critically and then join it. Okay, just make sure it's a little bit more wider. Okay, so as I said, there is a difference in y-intercept for all the graphs, but in this one you just have to be a little bit more critical, that's all. Okay, so does that kind of make sense, guys? So that was when the coefficients change. So when the coefficients are increasing, it becomes more thinner, skinnier, and as the coefficient is less than 1, but make sure it's greater than 0 as well, it's going to be more wider. Okay, that's all you got to remember for these ones. So that was this change in coefficients.